Hello, it's Eric here, and so welcome back to my series of videos on the latest frontiers in data science. And so, as you can hear from the background, there's a crackling fireplace going on, and the wind is howling outside, and there's a bit of snow falling. And so I'm actually recording this video in a cottage in the countryside, and but don't worry about me because I'm totally comfy, and so I'm warm, and I'm happy to be here to record this video for you. Yeah. And okay, so today we're on to frontier number 4. Yeah. And so basically this series of videos is to talk about the biggest discoveries in the data science and statistical science over the last half century. Yeah. And so today we are on to topic number 4, which is Bayesian multi-level modeling, or just simply multi-level models. Yeah. So let me bring up that page. And so here we are. And probably multi-level models are the easiest to understand in the in the 8 topics, in the 8 biggest discoveries in data science over the last half century. Yeah. And so I mean there is a lot of material in this topic, but today I'm just gonna bring your attention to 3 of the most important developments in this discovery in data science. And so yeah, so multi-level models basically is to combine several sets of data to give you like an overall picture of what's going on. And so let's start with the earliest development, which was the panel data model. Yeah. And so let me give you an example. So let's say, for example, in a country there's a central bank, and the central bank is trying to control inflation by setting the appropriate interest rate. Yeah. And so let's say, for example, over time the central bank finds out that for every 1% increase in the interest rate, the central bank can control the inflation by decreasing the inflation by about 0.5%. And so therefore the effect is a 0.5%. Yeah, decrease or reduction in the inflation. Yeah. And so that's a kind of a time series data. And then but the job of a panel data model is basically to combine time series data with cross-sectional data. And so therefore the question that most researchers will ask is that yes, okay, so this 0.5% reduction is maybe applicable to this particular country, like for example the US. Yeah. But if you go to another country, like for example the UK, the effect may be just 0.4%. And then you go to yet another country like Australia, then the effect may be just 0.3% reduction. And so therefore the effect is variational. That means that it's changing from one sector to another sector, or you can say from one country to another country. Yeah. And so therefore the effect is not fixed. So it's like a 0.5% reduction in the US, 0.4% reduction in the UK, and a 0.3% reduction in inflation for the Australians. Yeah. So that's the earliest development of this multi-level model. And then so that's panel data. And then recently, in the past 30-40 years, panel data has moved to a new kind of analysis called partial pooling. Yeah. And so the partial pooling basically is to combine several data sets together to give you a better picture of the inflationary effect. Like for example, let's say I already have a group of countries, and I discovered that for 1% increase in interest rate, the central banks in that group of countries can reduce the inflation by 0.5%. That's for the whole group. And so let's say, for example, now I have a new country, and as a new country, and I collected some data, and I found out that let's say, for example, this new country is New Zealand. Yeah. And so I collected some data from that country, and I found out that for every 1% increase in the interest rate set by the central bank, the reduction in inflation is let's say, for example, 0.6%. And so this 0.6% is different from the 0.5% on average for the whole group. And so then the question is how do I combine this 0.5% with the new 0.6% for New Zealand? And the reason why you want to combine this 0.6% with the 0.5% for the previous group is because maybe you don't really believe in the 0.6% for New Zealand. Maybe this 0.6% effect is true only for a particular year. Like for example, this year New Zealand was having a lot of natural disasters, yeah, like earthquakes and and typhoons and thunderstorms and things like that, And so therefore, this 0.6% reduction in inflation maybe it's just because of the peculiarity of that particular year, like lots and lots of natural disasters, yeah. On a normal year, maybe the effect is only 0.5%. That means should be the same as the previous group, yeah. And so therefore, you want to combine this 0.6% for New Zealand with the previous group of 0.5% reduction, for all the other countries in the previous groups, And so therefore, if you combine them together, maybe the combined effect maybe is only a 0.55%, And so therefore, you say 0.55% is actually the effect for New Zealand, And so that's how you do partial pooling. So partial pooling basically is a combined, you combine several, data sets together. Like in this case, you combine a group of countries, measure the inflationary effect, and then you add the new data set in New Zealand, yeah, and then you get another inflationary effect, and so you combine the two sets of inflationary effects together to get a combined effect, And so that's the partial pooling. And then, so partial pooling naturally graduates to another kind of analysis called Bayesian analysis, yeah. And so Bayesian analysis is a kind of a probabilistic approach, And so if you're a Bayesian statistician, you will start with a prior belief, yeah, and then so you have a prior belief about the inflationary effect, and then you get some new evidence, and then your prior belief becomes your posterior belief, And so therefore, the example here is, let's say, for example, the previous group of countries, the inflationary effect is 0.5%, and so therefore my prior belief about the inflationary effect is 0.5%. But then, I get some new evidence. Let's say, for example, the evidence is coming from New Zealand, yeah, and then so I observe that the effect, the inflationary effect, should be 0.6% for New Zealand, yeah, and then so therefore, using this 0.6%, I can upgrade, I can sort of recalibrate, yeah, the original prior belief of 0.5%. So after 0.5%, you recalibrate by adding new evidence of 0.6%. Then maybe the final effect is that means your posterior belief about the inflationary effect is combining 0.5% and 0.6%. That means maybe around about the 0.55%, And so therefore, Bayesian analysis, or another way to say it is Bayesian updating, is you get some new evidence and then you adjust your prior belief so that it becomes a posterior belief, And so the example that I give here is, the prior belief of the inflationary effect is 0.5%, but then you add some new evidence from New Zealand, and then that 0.5% becomes your posterior belief, yeah. So that becomes like 0.55% or something like that, And so that's a Bayesian type of analysis, yeah. And so in a nutshell, that's the multi-model analysis, multi-level model analysis, And of course, there's a lot more, technical material. And so I highly encourage you to look up those, mathematical models in details and learn more about it. But like I said, that this discovery in data science is probably the easiest to understand. It's just you combine several data sets together to give you a better picture of what you're trying to understand. All right, I'll see you in the next video. Bye.